Okay, let's look at some forms of energy with respect to flow rate. So you just saw the equations in the last video that talked about energy flow rate, and this typically applies to an open system, right? So if you look at this, this is a pipe, and this is the cross-sectional area of the pipe, and that cross-sectional area can be calculated by pi d squared over 4, right? So you have the pipe diameter, and you have a certain velocity, average velocity of steam going through this pipe. So the mass flow rate is going to be the density, whatever the density of that steam is, times the volumetric flow rate, right? So this might be, you know, cubic meters per hour, right, or cubic meters per second. We can rewrite this. So here you've got volumetric flow rate. We can rewrite the volumetric flow rate instead of cubic meters per second. We can write that as an area times the average velocity, right? So here you have meters per second. Here you have, here you have meters squared. Here you have meters per second. So this is going to give you cubic meters per second. So volumetric flow rate can be rewritten as average velocity times the area. So this is how you get a mass flow rate through a pipe. You know the area, you know the average velocity, you multiply those together, it gives you volumetric flow rate. Similarly, if you're given volumetric flow rate, you can find the average velocity if you know the area. So these two are interchangeable, and you should know how to do that. Again, that's basic math, right? Area times velocity. I think keeping track of units helps you keep track of what's going on to make sure you're doing things properly. And so from this now, if you have mass flow rate, right, you can get energy flow rate. You have a certain amount of internal energy, right? So the steam itself, you're going to find out later on in the course, we're going to have information about steam, right? At certain conditions, it's going to have a certain amount of internal energy. It might have a certain amount of other forms of energy. These are all going to get lumped into E. And this small e, remember, is energy per unit mass. So energy per unit mass, this would be something like kilojoules per kilogram. And here you have something like mass flow rate, kilogram per second. Kilograms cancel, you get kilojoules per second. This is energy flow rate, kilowatts. Let's look at internal energy now. Typically, internal energy is broken up into some different categories. We have what's called sensible energy, and that's associated with basically the movement of the molecules, right? Molecules are moving inside inside your system, right? That gives it a certain amount of internal energy. And that's something we can measure with temperature, right? Or with a thermometer. It's a resultant of temperature. Latent energy is associated with a phase of the system, right? So a phase, you might have, obviously you're going to have more energy at 0 degrees C as water than you have at 0 degrees C as ice, right? So those both have the same temperature, but they're going to have different phases, and that energy is the latent energy. And you guys have learned that in chemistry, I'm sure. Then you have chemical energy, which is just if you break bonds in a molecule, right? So water has a certain amount of energy associated with the bond between hydrogen and oxygen. And in fact, it requires a significant amount of energy to break that bond. So you know that you can, well, you probably know you can split water into hydrogen and oxygen with electrolysis, right? Applying electric current. And then if you combine the hydrogen and oxygen back, you're going to get energy out of the system, right? Releasing energy, and that's going to be that's basically atomic bonds. Finally, you have nuclear energy, and this is something that again you don't deal with too much in traditional classes, but this is basically energy within the nucleus of the atom, right? So if you split the atom of if you split a uranium atom, right, you're tearing apart the nucleus of the atom and creating smaller atoms. So you're tearing apart the neutrons and protons inside the actual core of the atom. So the thing you should take away from all these forms of energy are you're going to have thermal energy, which is a combination of this sensible and latent heat, or sensible and latent energy, right? And this is just molecular kinetic energy and phase of the system, right? So this is what you measure. This is thermal energy. Internal energy is a combination of all these four types of energy, right? It's sensible, latent, chemical, and nuclear. So internal energy includes the energy of the molecular bonds. It includes the bonds within atoms. So it's the sum, internal energy is the sum of all the microscopic forms of energy, right? And you can see that visually. Sensible and latent heat has to do with the individual molecules themselves. Chemical energy is, well, the movement of the molecules and interaction of. Chemical energy is between bonds, bonds within the molecule or bonds between atoms. And then nuclear energy is going to be within the atom itself, so splitting the atom.